Hey guys, this is a tube. It's filled with air right now and a few other things. So at the bottom you could see that there's a little piece of paper which kind of acts like a feather, and a penny which is much more dense. And you could turn the tube over and they'll fall from the top to the bottom. You could see, the paper got stuck that time, but you could see that the paper falls much more slowly than the penny. Even when they both fall at the same time, the paper will hit later. And I think that's due to the air in the tube, but we could test that out, because what I have here is a vacuum pump. Alright, I'll show you right here. Okay, and what I could do with the vacuum pump is suck the air out of this tube like this. So now that I sucked the air out of the tube, let's see how they fall. Alright, here we go. Let's see what happens differently. Whoa. What do you notice now that there's no air in the tube? How do you notice about the way they fall, the penny and the piece of paper? Happens quickly, pay attention. And now I'm going to let the air back in the tube. So here you can see the valve is sideways. Right here it's closed. But if I turn it, and now listen as the air rushes back into the tube. That sound was the air going back into the tube. So it was a vacuum with no air in it. Now there's air back in the tube. Now watch as they both fall. So for a moment they hit at the same time when there was no air in the tube. But now, once the air is back in, that's the reason why the paper flutters. Only due to the air. The paper wouldn't flutter, it would just fall straight like the penny and hit at the same time. But it flutters and lags behind only because of the air. So our lesson is that in a vacuum, where there's no air, everything falls at the same rate. But when there is air, different objects are more affected and lag behind.